Hi, this is Isha. You're watching a video with justtutors.com. In today's video, we'll be learning about coordinate geometry. And in this lesson, we'll first cover the section formula and then we'll work with the area of triangle. So now let's begin our lesson with some warm-up questions to try with. So you can pause the video here to try these questions, and once you're done, let's check our answers. In the first one, we need to find the distance between the 2 points. I hope you remember the distance formula. So using that, the distance between these 2 points will be 5 units, and the distance between these 2 points is under root of 170. The next question says that determine if the given points are collinear. So they will be collinear if the sum of two sides is equal to the sum of the third one. So these are the values that you will get, and if you have got the same values, then they are collinear. In the last one, we need to prove that the given points A, B, C are coordinates of a right triangle. So if you're calculating the values of if you're calculating the length of each of the side for a triangle, and if it's verifying your Pythagoras theorem, then it'll be a right angled triangle. And yes, in this question, these points are representing a right angled triangle. With this, we are good to move to more learning with coordinate geometry. Let's begin with the section formula here. So in section formula, first let's have a look to internal division. What will happen if a particular line segment is divided internally? So here the point P, if you can see in this picture here, which is represented by x comma y, is dividing the line A, B, which is represented by x1, y1, x2, y2 respectively, in a particular ratio of m ratio n. Here in the picture I've marked it. So if you want to calculate the value of x, that is the point where P is standing on the coordinate x, so for that we'll use m multiplied by x2 plus n multiplied by x1 and divided by m plus n. To calculate y, that is the point P on y coordinate, then we have m multiplied by y2 plus n multiplied by y1 divided by m plus n. This is the section formula for internal division. Pause the video here, have a good look at this formula, try to memorize it really well. Let's move ahead to work with the section formula when you see that your point P is exactly the midway in your line segment. That is, now we are working for a midpoint. So if you think of a midpoint, then the line segment will be divided into ratio of 1:1. So it's like m to n is basically 1:1. So then instead of m and n, we simply replace them by using number 1. So this is what we have as the generalized formula to find out the midpoint in a given line. x2 upon x1 plus x2 upon 2 and y1 plus y2 upon 2. This is how we calculate the point P. Now moving ahead with this and working for the external division, it's similar to what we have worked with internal division. Only the difference is that this time the point P is not between A and B, it's outside that point. And make sure that it is a collinear point, like all the 3 points are collinear, that is, they're lying in a straight line. So this P will be dividing AB externally in a ratio of m to n, as we have learned for internal division. However, a very small difference in this formula will make all the differences. That is, we are going to choose the operation of minus in between the terms. Here again, using the same but changing this operation sign from plus to minus, mx2 minus nx1 m minus n. For y, my2 minus ny1 divided by m minus n. This is the section formula for external division. Take a pause with this video and try to memorize it really well. Let's move ahead and let's look one example with this. We need to find the coordinates of the point which divides the line segment joining these given points in the ratio of 3:1 internally. So we'll be using this formula where we had the operation sign of plus in between, and keeping the given values in this equation, this is our answer. When you're marking the values like here, if you want to be careful how to mark the points x1, x2 and y1, y2, so you need to be careful that if you're working with the first point, here this 4 will be x1 and minus 3 will be y1. Similarly, if we are looking through the next point, it's x2 and then it's y2 there. So now with this we are good to move ahead, and let's work with this area of triangle. This is a formula, a generalized formula how to work with the area of a triangle inscribed in a geometric plane as shown here. A, B, C are the 3 points which are not collinear points. They are forming a triangle. They are given with different coordinate points, that is x1, y1, x2, y2, x3, y3 respectively for A, B and C. And this is how we use the formula, that is half x1 and in brackets you put y2 minus y3 plus x2, y3 minus y1 plus y3, y1 minus y2, and then completing the brackets we have half, because we have the formula of area of a triangle as half base into height. Similar is what we are doing here. Now with this we have another example that we can discuss together. Here again we are going to find the area of the triangle whose vertices are given to us. So area of a triangle is formed and we'll be just simply using the given values in the equation. So x1 will be the point A, so this 1 will be x1, comma y1 for A1, then minus 4 for B is x2, comma 6 will be y2. Similarly, minus 3 comma minus 5 will be x3 comma y3 here. So if you're calculating and putting all the values in the equation here, you'll be getting the answer as 24 square units. Make sure that when you're writing the area, the units are squared. With this, you have some practice questions to practice here. So you can pause the video, try all your practice questions, and when you're done with it, make sure that you check your answers with the answer slide provided at the end. Thank you for watching this video. For more, please visit justtutors.com.